Hello all. Now in the previous lecture we have seen the series and parallel combinations of resistors. Now we will see the series and parallel combinations of inductors and capacitors. As we know, the inductor will be like this. So I am considering two inductors here. These two inductors, namely L1 and L2, both are connected in series, and a voltage is applied across these two inductors. So some current will be flowing here like this, and this current will come and enter in the inductors like this. We already know now the inductor L1 and L2 both are connected in series. So when inductors are connected in series like this, then the total inductance LT can be written as same, the sum of all the individual inductance values. So L1 plus L2. This formula is very much similar to the resistor. And the equivalent circuit, if this circuit is simplified, then the equivalent circuit is having a single inductor like this. Sorry, this is minus. And this is supply voltage V, and this is the current flowing here, and this is LT. So this circuit can be replaced by this circuit. This is series combination of inductors. So the total inductance can be written as the sum of individual inductances. If we have more number of inductors, let us say the total inductance will be, if we have more number of inductances, that means L1, L2, L3, so on up to L, we have n number of inductors, and all these inductors are connected in series, then the total inductance LT will be equal to L1 plus L2 plus L3 plus L4 plus so on plus LL. So all the inductors will be additive. So this formula is very much similar to the resistance. So this is for series connection. And in the same way, if we want to connect the inductors parallelly, let us consider here also I am considering two inductors, namely, uh, I'm sorry, I am considering two inductors, namely L1 and L2. These two are connected in parallel. I have already given you how we can estimate the parallel and series connection in the previous video. So some voltage V is applying here. So now L1 and L2 are connected in parallel. The current I is flowing here, and this current is dividing here into I1 and I2. Sorry, we take this as uh, we take this one as I2, which is flowing in inductor 1, and that will be okay, right. Now I1 and I2. When these two inductors are connected in parallel, then the total inductance can also be written similar to the resistance value, which is 1 by total inductance is the summation of reciprocal of individual inductances. We have L1 and L2 only, so that's why 1 by LT is equal to 1 by L1 plus 1 by L2, and the equivalent circuit will become like this. This is LT, and this is the current I flowing. This is the supply voltage V is applying here. And if we have n number of inductors, then the total inductance ILT will be given as 1 by L1 plus 1 by L2 plus so on plus 1 by Ln. This is how we can write the formula for the series and parallel connection of inductors. And by observing these two formulas, by observing this formula and this formula, by observing these two formulas, you can clearly see these two formulas are very much similar to the resistance. So that's why the properties of resistor and inductors are very similar. In series and parallel combinations, the properties will be very similar. Then what will be the capacitor? We will see now. I am erasing. Now, capacitors are completely different when compared with inductors and capacitor. I mean, inductors and resistors. Because inductors and resistors both are one kind, whereas capacitors are will be opposite to inductors and resistors. We will see the series and parallel combinations now. Now, let us consider two capacitors, namely C1 and C2. Both the capacitors are connected in series like this. Uh, some voltage is applying here, and this is the current I is flowing. This is the applied voltage. This is capacitor C1 and capacitor C2. When these two capacitors are connected like this in series combination, then the total capacitance is the reciprocal of the total capacitance is equal to the sum of reciprocal of individual capacitances like this. As I said, R and L, resistor and inductor, both are same kind of elements, but the capacitor is completely opposite to it. So that's why we are getting this formula here. If you want the derivation, all these equation derivations, you can go through the textbooks also, but I am not interested to derive here, right? So this is the formula 1 by Ct is equal to 1 by C1 plus 1 by C2. If we have n number of capacitors, then the total capacitance will be written similarly, which is 1 by total capacitor is equal to uh, 1 by C1 plus 1 by C2 plus 1 by C3 plus so on 1 by Cn. So this is how the total capacitance will be calculated for the series combination. This is series combination, series connection of capacitors, right? What if two capacitors, namely C1 and C2, are connected in parallel? So some voltage V is applied across the parallel combination, and the current I is flowing here. Here it is going I1, I2 is going here, and this is C1, this is C2. And now C1 and C2 both are connected in parallel. Now the total capacitance CT can be the addition of individual capacitances like this. In parallel connection, the total capacitance will be the addition of individual capacitances, which is quietly opposite to resistor and inductor parameters. So if we have a number of capacitors connected in parallel, then the total capacitance will be C1 plus C2 plus C3 plus so on to Cn. So that means resistor, inductor, both will be like elements, whereas the capacitor will be a different element. So in resistor and inductor, series connection means we will add to get the total resistor or total inductance value. Parallel connection means we need to add reciprocals, reciprocals addition. For capacitor, this is completely different. This is completely different for capacitor. What is it for series? Reciprocal addition to get the total capacitance, and for parallel simply add like this. Okay, so this is how the series and parallel combinations of inductors and capacitors will be, and the equivalent inductance and capacitances will be. Okay, in the next class we will do problems on series and parallel combinations on resistors only, not inductors and capacitors. You can do inductors and capacitors, you can practice by your own. Thank you.